let's look at some more examples of radicals. So we've talked about the square root of 25 is just 5, no more radical. The square root of x to the 8th, and you're going to say how many groups of 2 are in here that I could take out, and the answer to that is x to the 4th. And then we have this example over here to the right. It says the square root of 144 x to the 6th. So the radicand now has numbers and variables. And the way that I like to do this is I like to split it up into two different radicals, because we kind of treat the numbers differently than the variables. So I like to call this the square root of 144 times the square root of x to the 6th. Now I can separate them in my brain. What is the square root of 144? Well, that's 12. And what is the square root of x to the 6th? Well, that's x to the 3rd. Okay, so this is the answer here, 12x to the 3rd. I always like to separate my numbers and my variables. I'll even separate, if I have x's and y's, I'll separate the x's from the y's. And then we have one more example to look at, the square root of negative 25. And remember, if you have a negative inside of a radical with an even index, it's not a real number. It's going to be an imaginary number. So my index here is 2. They don't write the 2. I don't know why. I'm trying to talk to the community of mathematics and say just write the 2. So the square root of negative 25, the answer is not a real number.